This video is all about arithmetic and geometric progressions. So we are going to solve for series and sequences. Arithmetic progression, these are the formulas that are going to be used. But first, let us define what is arithmetic progression. So arithmetic progression is a sequence such that the difference between any two consecutive terms is the same constant. So we have this formula for the last term or the nth term of an arithmetic progression. We have a sub n is equal to a sub 1 plus n minus 1 times d. For the sum of n terms, we have the formula S is equal to n over 2 times a sub 1 plus a sub n, or S is equal to n over 2 times 2 times a sub 1 plus n minus 1 times d. Now for your S sub 1, a sub 1, that is the first term. For a sub n, that is the last term or the nth term. For n, that is equal to the number of terms, and d is the common difference. Yung common difference is yung sinasabi ko kanina na difference between any two consecutive terms. Okay? So these are the formulas that we are going to know or familiarize with in computing or solving arithmetic progression problems. Now let's have an example. From the sequence 1, 4, 7, 10, and so on, find the 30th term. So ang hinahanap natin dito ngayon is the 30th term, or let's say that is a sub 30. Yan yung unknown natin. Now let us write the given parameters. So, yung given natin is 1, 4, 7, 10. So, a sub 1 natin, which is the first term, that is equal to 1. Of course, missing yung last term natin. Yung n natin, since we are looking for the 30th term, let us assume that the 30th term is the last term. So, yung number of terms natin dito will now be equal to 30. And then, for the common difference, how do you solve for the common difference? Sabi natin kanina sa definition, that is the difference between any two consecutive terms. So, let's have a sub 1 and a sub 2. So, that will be a sub 2 minus a sub 1, and that is equal to 4 minus 1. So, your common difference D will be equal to 3. So, let's try to check kung yung a sub 3 and a sub 2, yung difference ng a sub 3 and a sub 2 will also be equal to 3. So that we can say that the sequence given is an arithmetic progression. So, let's have a sub 3 minus a sub 2, and that is 7 minus 4. Therefore, the common difference is equal to 3. So, with this, we can say that the example given, the sequence given, is an arithmetic progression. Now, let's proceed to the computation of the 30th term. So, what is the formula in getting the last term or the 30th term? So, we have this formula, a sub n. Okay, so yung general formula muna yung isulat natin. A sub n is equal to a sub 1 plus n minus 1 times d. From the given parameters, okay, so ang hinahanap natin is the 30th term, which is si a sub 30. And then this will be equal to a sub 1. A sub 1 natin is the first term, that is equal to 1, plus n natin is the number of terms, which is 30 na inassume natin. So 30 minus 1, and then the common difference times 3. So if we are going to compute this one on your calculator, so you can pause this video and then input this equation to your calculators, and the answer for this problem will be equal to 88. So that is the 30th term of the given sequence. Okay, so let's have another example under arithmetic progression. So find the sum of the first 100 positive integers. So this time, ang hinahanap naman dito is the sum of the first 100 positive integers. So, sulat muna natin yung given natin. Of course, 100 positive integers. So, yung a sub 1 natin is obviously that is 1. Okay, so positive lang kasi. So, mag-start lang tayo from 1. And then, yung last term natin, let's say since 100 siya, so a 100, that will be equal to, last term natin, of course, that is 100. Kasi positive integers yung tinatanong dito or yung given. And then n will be equal to, of course, 100. And then the common difference will be, let's say that is 1. Okay? So, yung solution na gagamitin natin dito will be S is equal to n over 2 times 2 times a sub 1. Okay? So, 2 times a sub 1 plus n minus 1 times d. So, we can use this formula to get the sum of the first 100 positive integers. So, s will be equal to n natin is 100 divided by 2, and then 2 times a sub 1 natin is of course 1 plus n 100 minus 1 times 1. So, if you're going to compute this one on your calculators, ang lalabas na sagot will be equal to 5,550. Okay? So, ito yung isang formula. If you recall, meron tayong dalawang formula na gagamitin. So, now let's use this one and see if we come up with the same answer when we use this formula. So, this is solution number 1, and let's have a solution number 2 here. So, S will be equal to n over 2 times a sub 1 plus a sub n. So, S will be equal to 100 over 2 multiplied by 1 plus 100. Then, computing this one on your calculators, S will be equal to 5,050. So, they are the same. So, that is how you solve for the sum of the terms given an arithmetic progression. Let's have another example under arithmetic progression pa rin. So, if the first term of the arithmetic progression is 3 and the 10th term is 39, what is the common difference? Okay. So, isulat natin yung mga given natin. So, given tayo ng first term, okay, si a sub 1, that is equal to 3, and the 10th term, so a sub 10 will be equal to 39. And assume natin that since we are given a sub 10 here, assume natin that the number of terms given in this problem will also be equal to 10. Okay? So, if we are going to use the formula for the nth term, that will be equal to, ito yung formula, a sub n is equal to a sub 1 plus n minus 1 times d. So, ang hinahanap natin dito is si common difference. So, we are going to manipulate this formula. Since given tayo nito, si a sub 1 and si n. So, transpose natin to the other side. So, that will be equal to a sub n minus a sub 1 is equal to n minus 1 times d. Now, we are going to get the value of d. So, ang gagawin natin dito is to eliminate n minus 1. And to do that, we are going to divide both sides by n minus 1. So, therefore, the formula for the common difference will be a sub n minus a sub 1 divided by n minus 1. So, substituting the given values to the formula, this will be equal to 39 minus 3 divided by 10 minus 1. And that will be equal to 4. Okay, so you can compute this one on your calculators. Okay. Now let's talk about geometric progression. So let us define what is geometric progression. It is a sequence such that the quotient of any two consecutive terms is the same constant. So kanina is the difference, ngayon naman is the quotient. So we have this formula for the last term of a geometric progression. The nth term, we have a sub n is equal to a sub 1 times r raised to n minus 1. For the sum of n terms, we have the formula s is equal to a sub 1 times r raised to n minus 1 divided by r minus 1. So, yung a sub 1 natin is of course the first term, a sub n last term, n is the number of terms, and now r natin is the common ratio, which is the quotient of any two consecutive terms. So let's have examples for geometric progression. Find the 15th term of the geometric progression 3, 6, 12, 24. So sulat muna natin yung given natin. So a sub 1 natin is 3. And then since 15th term yung given dito, so let's assume that there are 15 number of terms. Okay? So n yon. N will be equal to 15, and then yung common ratio niya will be the quotient of any two consecutive numbers. So let's have C a sub 2 and a sub 1. So yung R natin is equal to 2. Now for our solution to get the 15th term of the geometric progression, we have a sub n is equal to a sub 1 times r raised to n minus 1. So, yung 15th term natin, so that is a sub 15 is equal to 3 times r natin is 2 raised to n minus 1. So, 15 minus 1. Therefore, if you compute that on your calculator, that will be equal to 49,152. So this is the 15th term of the given geometric progression. So let's have another example. Find the sum of the first 15 terms of the geometric progression 3, 6, 12, 24. So same geometric progression, but hinahanap ngayon is the sum of the first 15 terms of the geometric progression. So, ano ngayon yung formula na gagamitin natin? Or, sulat muna natin yung given natin. So, that is a sub 1 is equal to 3, n is equal to 15, and then yung r natin is equal to 2. So, solution natin to solve for the sum, okay, that is equal to a sub 1 times r raised to n minus 1 divided by r minus 1. So let's plug in the value. So this is 3 times r. So 2 raised to 15 minus 1 divided by 2 minus 1. Therefore, yung sum ng first 15 terms of the given geometric progression is equal to 98,301. Okay, so that is how you solve for the sum of the terms given a geometric progression. So that is all about the arithmetic and geometric progression. Thank you for listening and watching.